Let's also do question 4, which looks kind of similar, right? Once again, we have a 5-foot ladder leaning against a wall. So it's exactly the same problem. But we have a 5-foot ladder leaning against a wall, slipped in such a way that its base is moving away from the wall. So again, here's the base moving away from the wall. So I'm going to call that B as well. And we know that dB dt is 6 inches per second, but since I'm using feet here, I'm going to be consistent and use feet. So this is going to be 1/2 of a foot per second. And at this particular moment, B is 4, and we're looking for how fast is the angle between the ladder and the floor changing, right? So that's theta. So we're looking for d theta dt is question mark at that instant. Okay, so we need a relationship between these rates of change, but we're always going to start with a static relationship. So what I know is that the relationship between theta and b and 5 is cosine, right? So I could say cosine of theta is the adjacent over the hypotenuse, so then b is 5 times the cosine of theta. And I'm going to take the derivative of both sides with regard to t. So dB dt is going to be -5 times the sine of theta times d theta dt. And let's see, dB dt I know is going to be 1/2 foot per second. And this is going to be -5. Now, sine of theta is just going to be, I could drag out my calculator, I could figure out what theta is, but at this particular moment, again, b is 4, so this has got to be 3. So sine of theta is just going to be 3/5 times d theta dt. And, and this is 5 feet, right? That was 5 feet, the constant. So that when I solve for d theta dt, as far as the units are concerned, I can cancel out my feet. And I end up with kind of this strange, I have something per second, right? So I'm going to divide both sides by -3. So I have -1/6, right? Questions per second is d theta dt. And what we can remember is that d theta dt has got to be in radians, right? So this is going to be radians per second, and radian is a little ambiguous. When we talked about radians, remember, it was the ratio between the circumference and the radius, if I remember correctly. But this has got to be radians per second. And if we wanted to convert it to degrees, you could do that too.